Hi guys, I go by the name of Kamakelo. I'm widely known as King K and Harry. In today's revision class for Physics 171, we're gonna look into circular motion and gravitation. We will be solving problems involving the centripetal forces, the speed, the radius of revolution, as well as the period of revolution, including the object mass. So our biggest aim is to basically analyze and describe the forces that are acting on common objects in circular motion. As we know, the motion of an object can be explained using the Newton laws, kinematic concepts, and also the vector principles. In these two chapters, we will see how some of these concepts and principles can also be used to describe and explain the motion of an object in a circle. So firstly, you need to be able to define the concept of uniform circular motion. So a uniform circular motion occurs when a body moves in a circular path with a constant or a uniform speed. Then we say that an object is in a uniform circular motion. And then there's a terminology referred to as the angular displacement. So the angular displacement is simply the angle through which a point or a line has been rotated in a specific sense about a specific axis. So in a practical sense, if you have a particle moving in a circular path, and this particle moves an arc distance s, and then this is our radius. Then this will be our angle theta. So this angle theta here is what we refer to as the angular displacement, the angle through which a point has been rotated in a specific sense. And this angular displacement can be related to the arc length s and the radius by the equation as arc length is equals to the radius multiplied by the angular displacement. Therefore, the angular displacement will be equals to what? To the arc length divided by the radius. So this is the angular displacement. It's a quantity that is measured in radians. Okay, so one important thing you have to be aware of when it comes to angular displacement is that the angular displacement can be given in revolutions, radians, and can also be given in degrees, but it has to always be in radians. So if it is given in revolutions, you have to convert it to radians, and if it is given in degrees, you still also have to convert it to radians. So we know that by context, one revolution is basically equals to 2 pi radians. One revolution is equals to 2 pi radians, and this is also equals to 360 degrees. Okay, so this is the main formula that you can use to convert your revolutions to radians and your degrees to radians in order to have your angular displacement in radians. So understanding this relationship is also crucial in solving many questions in circular motion. You will see and notice that as we do questions. And then another terminology, we have the angular speed, which is represented by the letter W. So it's a Greek letter omega, and it is defined as the rate of change of angular displacement. Mathematically, it's given by the change in angular displacement over the change in time. And its units, its radians per second. Then we also have the angular acceleration. We also have the angular acceleration, which is represented by the Greek letter alpha, and is defined as the rate of change of angular speed. Okay, so change in angular speed over the change in time, and it is measured in radians per second squared. Okay, so one can notice that here we are applying kinematics concepts, but now in what? In circular motion. Remember, in linear motion, when we had to find the velocity is the change in displacement over the change in time. But now here we are dealing with what? A circular motion. So basically, the change in velocity is the change in angular speed, and then the change in time, it is still the change in time, right? And then the change in displacement in circular motion is the change in what? It is the change in angular displacement. Okay, so we are basically shifting the idea to what? To the fact that we are focusing on a circular part, right? So this also tells us that even those kinematics are equations for linear motion, those that states that the final velocity is equals to the initial velocity plus the acceleration by the change in time, do also apply in what? In angular motion. But in angular motion, you have to take note that now in this case, your V final is basically what? Your angular speed final, and then this is going to be equals to the angular speed initial plus what? In this case, we're going to have the angular types of kinematic equations, they do also apply in what? In circular motion. Okay, so what we just we just did here is the Newton's law of motion, but now it is applied in what? In circular motion. Okay, now we look further into circular motion. There's also the concept known as rolling without sleeping. So when an object rolls without sleeping, it basically means the object rolls smoothly. So when we look deeper into the context, rolling without sleeping is a combination of translational and rotational motion, where the point of contact with the surface is instantaneously at rest. Okay, meaning that there is no any relative motion between the object and the surface. Okay, so therefore the velocity of point of contact will be what? Will be zero. That is the concept of rolling without sleeping. So now we just dealt with the application of Newton's second law in circular motion, whereby there's no any influence of a force. But we know that, again, by definition, a force is required to maintain a circular motion. That's where now the Newton's second law of motion comes into play. So let's apply the Newton's second law in circular motion. So now we shift our idea to the situation whereby now there's a force that is exerted on the object. Okay, so when without a force, people without a force, we know that there is no any circular motion. An object cannot travel in a circular path. Okay, so now this shift us to the following terminologies known as the centripetal force and acceleration. So a centripetal force is that type of force that allows the object to maintain a circular motion. Okay, I can use a scenario of a car as an example. When a car travels and it has to make a turn, okay, so in order for that car to make a turn, it's gonna experience some friction with the surface, right? So that frictional force is actually the one that is helping the car to turn. It's gonna point towards the center of the what? Of that smaller arc or circle, okay? And in that case, that means the frictional force is acting as what? As the centripetal force, okay? So now there's a centripetal force mathematically, this centripetal force uh, mathematically, this centripetal force is given by mvt squared over r. So how did we go about having this equation? Okay, so we know, like I said, we want to apply the Newton's second law in what? In circular motion. So we know that by Newton's second law, the net force is equals to mass multiplied by what? By the acceleration. Okay, but in circular motion, now the F net, which is the applied force. So your applied force will be the centripetal force. So it's equals to the mass multiplied by the centripetal acceleration. So your centripetal acceleration is given by the radius multiplied by omega squared. Omega, which is the angular speed. And this is going to be equals to the radius. Before I can explain this, let me first draw the sketch before I go further. If you can consider a particle, let me take it a bit higher. If you can consider a particle, why is this thing doing this? Okay, oh, I didn't open another page. So if you can consider a circular part like this, and there's a particle that is traveling, okay? So the centripetal force always points towards the center, always points towards the center, and which induces the centripetal acceleration, which as well points towards the center. So, and then, so this force, centripetal force, induces the centripetal acceleration, which causes the object to move at a certain velocity known the tangential, to move at a certain speed known as the angular speed. But we also have the tangential velocity, which acts tangent toward to this object, okay? Therefore, your centripetal acceleration will then be given by r multiplied by the angular speed, which can then be given by the tangential velocity divided by r and then squared. Therefore, from here, your centripetal your centripetal force will be given by the mass, the mass, and then multiplied by Vt squared. This is r squared, this is r, and then this will be r squared. One r will cancel one r, and then it will then be divided by r. Therefore, your centripetal force will be given by mvt v sub t squared over r, and it is measured in Newton. That is the centripetal force. So this is the application of Newton's second law in circular motion. So that is uh, the summary for circular motion. And then, like I said, we also gonna look into gravitation. So under gravitation, so Gravitation is basically the type of force that acts on an object when it's moving up and down, right? So now we wanna talk about the universal law of gravitation, which states that every particle in a universe attracts every other particle with a force that is directly proportional to their masses and inversely proportional to the square of the distance between them. So mathematically, we know that the gravitational force is equals to the gravitational constant and then multiplied by the mass of an object, and then multiplied by the mass of another object, and then multiplied by r squared. So this mass m1 is in most cases it's the Earth's mass, and m2 is the mass of an object, and then r squared is the distance between those two, between the Earth and that object. Okay, so it's the separation distance. Okay, so we know that by Newton's second law, F net is equals to ma. So for objects that are moving up and down, the gravitational force is the one that is acting on that object. So basically, the gravitational force is the F net. Therefore, you can have G m1 m2 divided by r squared is equals to ma, and then one mass will cancel. This mass will cancel this other mass. Therefore, you're gonna have what? Then from here you're gonna have we're gonna have our A to equals to G by m1, which is the mass of the Earth, over r squared. So this G is known as the gravitational acceleration. This G is known as the gravitational acceleration. So this gravitational acceleration depends on r. Okay. So this gravitational acceleration depends on the value of r, the separation distance between the Earth and the object. Okay. So basically, this r uh, this r is it's equals to the radius of the Earth, and then plus what? Plus the altitude. Okay, the height above the Earth's surface. Okay, so that is the first theory behind the universal law of gravitation. So we know that the Earth rotates, right? The Earth rotates. So as a result, Earth maintains what? A circular motion. Okay. So because the gravitational force is directed inwards and travels about the center of the Earth as the Earth turns, as the Earth turns, it creates what? It creates a centripetal acceleration. It creates a centripetal acceleration, which is also directed towards the center of the circle. It also creates what? The centripetal acceleration, which is directed towards the center of the circle. Okay, and and for we know that this gravitational this centripetal acceleration, is given by omega squared r, right? So and then where by Newton's second law, when we apply the Newton's second law, we know that the F net is equals to ma. So in this case, the F net is basically given by the normal force minus what? Minus the weight, right? Which is mass multiplied by the gravitational acceleration, and this is equals to the mass multiplied by where a, this is the centripetal acceleration, which is given by which is given by uh, the centripetal acceleration, which is given by tab omega squared r. So this is going to be minus omega squared r. And then from here, we have the normal force, which is equals to the weight. That is just mg, right? So we're going to have mg minus m, and then by the gravitational acceleration is equals to minus m omega squared r. And then we can divide everything by m, by m, by m. So we're going to have g to be equals to, I take it to the other side, gravitational acceleration minus omega squared r. And then this g, it's what we refer to, this g is what we refer to as the free fall acceleration. So this g is what we refer to as the free fall acceleration, and this g is the gravitational. This is the gravitational acceleration, and then this one is the centripetal. This one is the centripetal acceleration. Okay, so now this is the context of a free fall acceleration. That's what I wanted to introduce by doing this. So the free fall simply refers no effect of what? Of gravity, right? The gravitational acceleration is zero. Okay, when an object there it's in free fall motion, its gravitational acceleration is just zero. And this is mostly the case that occurs at a higher altitude above the Earth's surface, where there is no any gravity, or gravity effects are not dominant. So this is the basic theory that you have to understand in in uh, in in circular motion and gravity. So it will help you solve some questions that you come across. And then one last tip, be able to relate the revolutions with the number of days, with the degrees, and all that, and be able to convert one from the other. Because in some questions, you might think that there's a missing variable while it is given there. Okay, so now let's look into some questions. Just take them from my clipboard here, and then questions on gravitational acceleration. So let me start with this one. So this question says, on Earth, the mass is equals to 5.98 times 10 to the power 24. The gravitational acceleration is 4.9 meters per second squared at an altitude of. So now we have to find the altitude. We know that by definition, the gravitational acceleration is derived from Newton's second law. The gravitational acceleration is given by the gravitational constant multiplied by the mass of the Earth divided by the separation distance. So the separation distance is given by the radius of the Earth plus the height above the Earth surface. Okay, by the height above the Earth's surface. So pictorially, can say this is the Earth and this is the particle that we are talking about. So this distance from the center of the Earth is, so this is the, we know this will be the radius of the Earth. Then this is the h, which is the altitude, the distance from here to there. So this whole distance is the separation distance r. So therefore, your AG will be equals to G multiplied by the mass of the Earth divided by the radius of the Earth plus the height above the Earth's surface squared. Then we continue. So the question says the gravitational acceleration is 4.9 at an altitude of. So we have to make h subject of the formula. So in making h subject of the formula, this by this squared will be equals to g by me divided by ag. Okay, then now let's continue and find the solution. So we're gonna have h to be equals to g by the mass of the Earth square root of g by the mass of the Earth over the gravitational acceleration, and then minus what? The radius of the Earth. Okay, so therefore we know the value of the for the radius of the Earth. We know the gravitational constant. So we can substitute what we have and then find the unknown. So h will basically be given by the square root, right, of what? Of the gravitational constant. So I'll just write them there. You'll substitute them. So we know that g, which is the gravitational constant, has a magnitude of 6.67 times 10 to the power minus 11 meter cubed per second squared kg. And then the mass of the Earth is given in the question. And then also the gravitational acceleration ag, it's also given to be 4.9 meters per second. Then the mass of the Earth is also given to be 5.98. Is it 5.98? Yes. Yes, 5.98 times 10 to the power 24. 5.98 times 10 to the power 24 kg. So now we also have the radius of the Earth. It's just a constant RE, and it has the magnitude of the radius of the Earth. It has the magnitude of 6.37 times 10 to the power 6. So you're gonna substitute all these values on that equation, and you're gonna get that your altitude height above the Earth's surface is 2.65 times 10 to the exponent 6 meters. So the altitude is 2.65 times 10 to the exponent 6 meter at an gravitational acceleration of 4.9 meters per second. So now we are done with that question. And then let's move on to another question. Okay, before I go there, just to give you more little understanding into this thing of a gravitational acceleration. So here you are basically trying to calculate, or okay, at what altitude is the gravitational acceleration? 4.9, right? Hence, in the beginning, I said this r, which is the separation distance, affects the value of what? of the gravitational acceleration. So at different levels on the Earth's surface, I mean at different altitudes, there's a certain gravitational acceleration until where it is zero, whereby now an object is experiencing a free fall. Okay, now let's move on to the second question. The second question says, imagine a neutron star with a radius of 20,960 kilometers to be rotating about 4.6 revolutions per second. Then we are now for the material on its surface to remain in place during this repeat rotation, the minimum mass of the star should be. Okay, so here we wanna apply a concept of free fall motion. Why does it apply? They are talking about a neutron stars. Neutron stars are far above the Earth's surface. Okay, are far above the Earth's surface, and they circulate around the sun as the Earth turns. Okay, so for the fact that they are located at a higher altitude, okay, where the gravitational forces are less significant, then that means the neutron stars are in free fall acceleration. Okay, they are in free fall motion. Therefore, in solving this question, we can use the equation that the free fall acceleration is equals to the gravitational acceleration minus angular speed squared multiplied by r, where omega squared r is the centripetal acceleration, because neutron stars are the most dense stars in the universe and are located at a very high altitude. Then there is a zero gravity, okay, which means there is no net force, right? So this condition, it is achieved through a reference frame that is in free fall motion, okay? Therefore, the free fall acceleration is just simply a zero. So zero will be equals to ag minus angular squared r. Therefore, from here, the gravitational acceleration will be equals to the centripetal acceleration. Okay, so all this also has proven to us that under the effect of free fall, or when an object is in free fall motion, then the gravitational acceleration is equals to what? To the centripetal acceleration. Okay, so therefore, um what are you gonna have? We know now we can continue and solve for the unknowns, right? So we know that the gravitational acceleration is given by what? By the gravitational constant multiplied by what? By the mass over what? Over r squared, and then this is going to be equals to omega squared multiplied by r. So now we have to make m subject of the formula. That's what we are looking for. So we make m subject of the formula, then we're gonna have omega squared, then r multiply r, we're gonna have r cubed divided by what? By g. So this is the equation that we're gonna use to find what? The mass. Okay, this is the equation that we're gonna use to find the mass. Okay, so let's continue and find what is required. So we don't have omega, the angular speed, and we know that omega, it's given by the change in angular displacement over the change in time. Okay, so when we look back into the question, let's go back into the question. The question says, imagine a neutron star with a radius of 20,906 to be rotating about 4.6 revolutions per second. Okay, so this star is completing 4.6 revolutions in a second. Okay, so this tells you that your angular displacement theta, the change, it's what? It's 4.6 revolutions, since it makes 4.6 revolutions per second. And then when you convert 4.6 revolutions to radians, then you're gonna get that this is 46 over 5 pi radians. Okay, when you convert 4.6 revolutions to radians. Okay, so this is the angular displacement. Okay, and the changing time is just 1 second. Therefore, this means that your angular displacement is basically going to be equals to 46 over 5 pi radians. What is time? They say 4.6 revolutions per second. So time is just 1 second. So these, and then this will give us our angular displacement. This will then give us our angular displacement to be, this will then give us our angular displacement W to be equals to 46 over 5 pi radians per second. Now we have our angular displacement. We can go back. We said m is equals to omega squared multiplied by r cubed over g. So we have now omega to be 46 over 5 pi, and then this is squared. We're going to multiply by the radius. And then let's go back to the question. Is the r given? Yes, the r is given as 20,960 kilometers. So now we're going to convert it to meter. So when we convert 20,960 to meters, then its value is 2.096 times 10 to the power 7 meter. And then this is cubed. This is cubed. And then you're gonna divide this by G, which is the gravitational constant, and it has a value of 6.67 times 10 to the power 226. Right. And then we're gonna get that the mass is 1.002 times 10 to the power 26 kg. Perfect. And then now that's how we're gonna find the mass. Okay, as required. So this is the minimum mass of this star. You can see that by context, 1.00 times 10 to the power 6 is a very large number. So hence the neutron stars are very dense. So at a very higher altitude, there will be, where there is no any frictional force, like there will be under a full fall motion, since there's no any gravitational force that is acting on them, or there's no any net force. Right now we are done with this question. Now let's look into the last question, which is about based on circular motion. So in this question, now they say 100 kg car takes 4 seconds to turn from north to west around the corner. If the radius of curvature of the road is 30 meters, what force of friction do the car wheels apply? So there are many ways of solving this question, but I will only show you 2 ways. Okay, so now I'm sure that you've noticed that in most questions that I've been solving here in physics, I've been making use of the sketches. So it is very helpful in physics to like to to take the situation, okay, and make it more practical, okay, by drawing a sketch. That way, it is easy for you to see, oh, okay, this is what I'm actually supposed to do. This is how I can go about finding a solution to a question. So here they say 100 car takes 4 seconds to turn from north to south. So we can draw our campus. We have the north, we have the west, we have the south, and we also have the east. So it takes only 4 seconds for this car to take from what? For this car to turn from north to south. Okay. So by just looking at this, turning from north to south, and it took this car 4 seconds to turn from north to south, we can see that when we are talking about the car, there's a frictional force. The frictional force in this case, it is acting as what? As the centripetal force, and is the one that is causing this car to turn from east to what? To turn from north to west. I made east to north. I made a mistake, but not a huge mistake. Okay, so it's the one that is causing this car to turn from north to west. Okay, and and it only took 4 seconds to turn from north to west. Okay, so this basically tells us that the 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 angular displacement is 90 degrees, right? Because this is the 10, right? So we basically have an arc length. This is our arc length S, right? And this angle here will be our angular displacement. So our angular displacement is 90 degrees, which is pi over 2 radians. Okay, so now, so by making a sketch, we were managed to see that okay, the angular displacement here is basically 90 degrees, because turning from north to west, we know that from geography, this is the angle between these two points on campus is 90 degrees. Therefore, your angular displacement will be 90 degrees. Okay, so that is the usefulness of drawing a sketch in this case. Okay, so now we're gonna then talk about and then we spoke about this. So we have the angular displacement, right? So like I said, the frictional force here is acting as what? As the centripetal force. So therefore, that means the frictional force will be equals to what? To mvt squared over r, right? Then your vt is then equals to r multiplied by the angular speed. So this is r into angular speed, which is given by the change in angular displacement over the change in time. So then from here, this will be, Vt will be given by the radius r. So the radius of curvature is given to be 30, and this is multiplied by the angular displacement, which we found to be pi over 2, right, the radians per second. So for this change or in angular displacement, it took only how many seconds? It took it only 4 seconds. Okay, so we divide this by the time 4 seconds, and then you punch on a calculator, you're gonna get that the tangential velocity is 11.78 meters per second. Therefore, the frictional force will be equals to the mass, which is 1000 as given, and then multiplied by the tangential velocity 11.78 squared. And then we divide this by the radius of curvature, which is 30. So we're going to get that the frictional force has a magnitude of 4625.61 newtons. And that is the frictional force. Okay. And then another way of approaching this question is by using the concept of a period. Okay, you can use the equation that the tangential velocity vt is equals to 2 pi radians over period. Okay, but now when you use this equation, okay, yes, you are right to say that 2 pi. In this case, your angular displacement is what? It's 2 pi, which is for what? For one complete revolution, okay? So since we are using the context of one complete revolution, which is 2 pi, then we also have to consider what? The total time to complete this one revolution, right? Because one revolution is equals to 2 pi, so 2 pi. So we're gonna have to look for the time taken to complete this one revolution. How are we going to find that time? On the scenario, it is given that it takes only 4 seconds for this car to turn from north to west. So by interpretation, we can see that it will also take 4 seconds for this car to turn from west to south, and it will also take 4 seconds for this car to turn from south to west, and it will also take this car 4 seconds to turn from east to north. Okay, so now, when it turned, it started at north, it, it ended at north. So what does this tell us? Our period, T, which is what we are looking for, will be 4 plus 4 plus 4 plus 4, which is 16 seconds. So therefore, the period is what? It's 16 seconds. So it took this car 16 seconds to make what? To make 4 turns. And then it returns to its equilibrium position where it started, right? Therefore, your Vt in this case will be given by 2 pi and then multiplied by what? By the radius of curvature, which is given to be 30 divided by 16. And then from there, you will get that your tangential velocity is 11.76 meters per second, which is what we got in the previous question. Okay, so that is what I was referring to when I say you have to be able to relate the number of revolutions to the angular displacement to the radians, right? So that everything makes sense, right? Oh, okay, we talk about period. This VT, we have 2 pi here. If due to time, I won't be able to show you, but if there was time, I would show you where does this equation of 2 pi basically comes from, okay? But it is just derived directly from our equation that we know, which is Vt is equals to R multiplied by the angular speed, okay? So on that equation, when you take your angular speed to be equals to, your angular displacement to be equals to 2 pi, 2 pi, like you're gonna have Vt, right? It's equals to R by the change in angular displacement and then over the change in time, right? So maybe you might say you don't have the angular displacement, right? But it is given there. So maybe we say let's take it to be 2 pi. You make it 2 pi. When you make it 2 pi is one complete revolution. Hence why instead of dividing by changing t, you have to divide by period. The total time time taken to complete one full revolution, right? So that is the idea behind it. So understand these relationships, because you might thought you are not given a certain thing in a question, whereas it is there. Okay, it can even be given in terms of basic, guys. You don't know. Examiner can ask anything, can give you a kind. It says it takes the car 1 day to turn from north to west, and then you'll be like, yo, I'm not giving anything. So study those, and then ensure that you are well prepared for your exam. This will be the end of the lesson for the revision class on circular motion and gravitation.